day, everyone. Welcome to another episode of Quick Math Tutorials. Today, we are going to learn about properties of a parallelogram with proof. Before using the properties of a parallelogram in solving triangles, we need to prove each properties of a parallelogram. Property number 1. In a parallelogram, any two opposite sides are congruent. To prove this property, we have given the parallelogram HOME. We will prove that the line segment HO is congruent to the line segment ME, congruent or equal. Then we will also prove that the line segment OM is congruent to the line segment HE. Since we will try to prove the property number 1 saying any two opposite sides of a parallelogram are congruent. So we will prove this one. For our proof, we will use the two-column table. We have the statements and the reasons. So as you can see here in the table, we will just fill in the missing statement and the missing reason. So for number 1, the reason is given. So for our answer in the statement for number 1, we will just copy the given. So we have the parallelogram HOME. For number 2, we have the definition of a parallelogram. The definition is parallelogram is a four-sided plane with the opposite sides are parallel. So opposite sides are parallel. So we have the line segment HO is parallel to the line segment ME, and the line segment HE is parallel to the line segment MO. For number 3, we will draw line segment EO, and the reason is line postulate. Line postulate says a line contains at least 2 points. Since this is 2 points, the point E and point O, so we can draw a line. So we have now the line segment EO. For number 4, we have the alternate interior angles are congruent, or in symbol we have AIAC. So here in our illustration, the alternate interior angles are angle HOE, so this one, and the angle MEO. So these angles are alternate interior angles, and we can call them alternate interior angles since these two line segment HO and EM are parallel. So alternate interior angles is just applicable to parallel lines. And these two alternate interior angles are congruent. And another alternate interior angles are HEO and the angle MOE. They are also congruent or equal. For number 5, the reason is reflexive property. So for our statement, we have the line segment EO is congruent to itself the line segment EO. So that is reflexive property. So as you can see here in our illustration, the congruent parts are the angle, the side, and the angle. Hence, we can have the triangle HOE is congruent to this triangle, and the reason is ASA congruence postulate or angle side angle. So here in the illustration, we have angle side angle. So here in number 7, this is what we are trying to prove. So line segment HO is congruent to the line segment ME, and line segment OM is congruent to the line segment HE. And the reason is congruent parts of congruent triangles are congruent, or in symbol we have CPCTC. Since in number 6, we prove that these two triangles are congruent, therefore the congruent parts of a congruent triangles are congruent. Thus, we are done with our proof. Now, since we are done proving property number 1, by illustration, in a parallelogram, any two opposite sides are congruent. So we have this line segment HE is congruent to the line segment OM. And we also have the opposite sides, the line segment HO is congruent to the line segment EM. Now let's have the property number 2. In a parallelogram, any two opposite angles are congruent. Given the parallelogram JUST, we will prove that the angle JUS is congruent to the angle STJ, or the angle UJT, or this angle, is congruent to this angle TSU. Since in property number 2, it says that any two opposite angles are congruent. So we will try to prove the opposite angles, or these opposite angles are congruent. So here is our proof. So again, we will just fill in the missing statement and the reason. For number 1, the reason is given. So we will just copy our given. So we have the parallelogram JUST. For number 2, we will draw a line segment UT and line segment JS. So we have this one. We have two diagonals. The reason is line postulate. Again, line postulate says that a line contains at least 2 points. For number 3, we have the reason is parallelogram property number 1. As you can remember, earlier we proved this property number 1. It says that in a parallelogram, any two opposite sides are congruent. So for our statement, the opposite sides are JT is congruent to the line segment SU. And we have the line segment JU is congruent to the line segment TS. So these two opposite sides are congruent. Now for number 4, we have the reflexive property. Since we have two diagonals, so the reflexive property, we have TU is congruent to itself TU. And we also have the line segment JS is congruent to itself line segment JS. For number 5, triangle TUJ. So this triangle is congruent to the triangle UTS. So this triangle. So these two triangles are congruent. Another two triangles are STJ and JUS. So these two triangles are congruent. So for number 5, we can say that these two triangles are congruent since we have the angle, the side, and also these sides, the diagonal, since we have the reflexive property. So we have the SSS congruence postulate, or side, side, side. Or this one, the diagonal. This side, and this side, and this side. So the three sides of a triangle are congruent to the corresponding triangle. So for number 6, this is what we are trying to prove. Since these two triangles are congruent, so our reason is CPCTC. Therefore, the angle JUS, so this angle, is congruent to the opposite angle STJ. Another, we have UJT, or this angle is congruent to its opposite angle TSU. And we are done with our proof. So since we are done proving property number 2, in illustration we have in a parallelogram, any two opposite angles are congruent. So we have this angle and its opposite angle is angle M. So we have angle H is congruent to angle M. Another opposite angles are angle E and angle O. Thus, angle E is congruent to angle O. Next, we have the property number 3. In a parallelogram, any two consecutive angles are supplementary. Supplementary means the sum of two angles is equal to 180 degrees. To prove our property number 3, so we are given the parallelogram LIVE. So we will prove that the angle I and V are supplementary. We also have V and E and L and I. So they are supplementary angles. Since in property number 3, it says that in a parallelogram, any two consecutive angles are supplementary. So we will prove this one. So for our proof, for number 1, the reason is given. So we will just copy the given. So we have the parallelogram LIVE. For number 2, we have the line segment LI is parallel to the line segment VE. And the reason is that two opposite sides are parallel. This is from the definition of a parallelogram. For number 3, angle I and angle V are supplementary. The reason is same side interior angles are supplementary, or in symbol we have SSIAS. So this SSIAS, this is only applicable if the two opposite sides are parallel. Since these two opposite sides are parallel, so this same side interior angles, they are supplementary. For number 4, angle I is congruent to angle E, and angle V is congruent to angle L. So as you can see, this is, or the two opposite angles are congruent, and this is based from the parallelogram property number 2. So we already proved this one earlier, or it states that in a parallelogram, any two opposite sides are congruent. For number 5, the reason is an angle that is supplementary to one of two congruent angles is supplementary to the other also. So we have angle I and angle V are supplementary, and this is what we are trying to prove. So aside from angle I and angle V, we can also say that angle V and angle E are supplementary. Another, angle E and angle L are supplementary, and angle L and angle I are supplementary. Now we are done with our proof. Since we are done proving the property number 3, so here in our illustration, in a parallelogram, any two consecutive angles are supplementary. So here the consecutive angles are angle H and angle O. So we have the measure of angle H plus the measure of angle O is equal to 180 degrees. Another consecutive angles are angle O and angle M. So the sum of these two angles is equal to 180 degrees. Another, we have angle M and angle E. So the same, which is equal to 180 degrees. And last, we have angle E and angle H. So the sum of these two angles is equal to 180 degrees. For the property number 4, the diagonals of a parallelogram bisect each other. Given the parallelogram CURE with diagonals line segment CR and line segment UE that meet at point H. So here, we will prove that the line segment CR and line segment UE bisect each other, since in property number 4, it says that the diagonals of a parallelogram bisect each other. So we will prove this one. So for our proof, number 1, the reason is given. So we will just copy here the given. Next, for number 2, we have the line segment CU is congruent to the line segment ER. So the two opposite sides are congruent. And that is parallelogram property number 1. We already proved this one earlier. Next, we have line segment CU is parallel to the line segment ER. And the reason is, so these two opposite sides are parallel. And that is by definition of parallelogram. Next, we have angle CUE. So this angle is congruent to angle REU. So as you can notice, these two opposite sides are parallel and we have these two angles are congruent, and these two angles is what we call the alternate interior angles are congruent, or in symbol we have AIAC. Next we have the angle CHU. So we have this one, and the angle RHE. So this one. So these two angles are congruent by vertical angle theorem, or in symbol we have VAT. And for number 6, since here in our illustration, we already have the side, angle, and angle, so we can conclude that the two triangles CHU, see this triangle, is congruent to this triangle. And that is by S or side, AA or angle congruence postulate. Next, for number 7, we have the line segment CH is congruent to RH. And we have the line segment EH is congruent to the line segment UH. The reason is CPCTC. Since we already proved that these two triangles are congruent, thus the congruent parts of congruent triangles are congruent. And for number 8, this is what we are trying to prove. The reason is the definition of bisectors. When we say bisector, it cuts the line segment into two congruent parts, or into two equal parts. Since we are done proving property number 4, so here in our illustration, we have the diagonals HM and EO. Property number 4 says that the diagonals of a parallelogram bisect each other. So here we have the line segment HS is congruent to line segment SM. So we have this one. Another is the line segment ES is congruent to the line segment SO, or in symbol we have this one. For our last property, we have a diagonal of a parallelogram divides the parallelogram into two congruent triangles. So to prove, we have given the parallelogram AXIS with the diagonal AI, and we will prove that these two triangles are congruent. So for our proof, we have the given. So again, just copy the given. And for number 2, we have the line segment AX is parallel to the line segment IS, and the line segment AS is parallel to the line segment IX. So as you can notice, two opposite sides are parallel, and that is by the definition of parallelogram. And then we have, for number 3, angle XAI. So we have this angle and angle SIA. So this one, they are congruent. So again, these two line segments are parallel, and we have these two angles, and these two angles is what we call the alternate interior angles, and they are congruent. Or we have the AIAC, or alternate interior angles are congruent. For number 4, the reason is reflexive property. So we have the line segment IA is just congruent to itself, the line segment IAI. And for number 5, we have the angle XIA and the angle SAI, they are also congruent. And the reason is still the alternate interior angles are congruent. And since we already have angle, side, angle, so for our last part or number 6, the triangle AXI and the triangle ISA, they are congruent, or these two triangles are congruent, and the reason is ASA congruence postulate, or angle side angle. And we are done with our proof. For property number 5, in illustration, we have this diagonal EO. Thus, these two triangles are congruent. Or we can also have this diagonal, thus these two triangles are congruent. Now, we are done proving the 5 properties of a parallelogram. For my next video, we will now use these properties in solving the triangles. And that ends our quick math tutorials. If you like the video, please click on the like button. If you have questions, just leave a comment below. And to be notified on my next video, please click on the subscribe button. Thank you. Bye!
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.